Given the Beer's Law data acquired for this compound, calculate some of the following problems. The problem that is encountered with this data is that if you plot it, you'll see that there is a linear relationship which starts dropping off after 100 ppm. That means that the linear dynamic range is effectively only going to go up to about 100 ppm, and none of the data beyond that can be used in the calculations. You can only use the data that is within the dynamic range. So if we plot this data, we can see that there is a linear Beer's Law relationship having an equation of y is equal to 0.0145x plus effectively 0. So if the unknown had an absorbance of 0.879, what is the concentration of the unknown? We're going to use Beer's Law, which is really going to simplify down to that. So 0.879 is equal to 0.0145 times the concentration. The concentration is 60.6 ppm. Calculate the sensitivity. Well, I've already done that for you. If you remember that the sensitivity is simply the slope of the line, then the sensitivity is 0.0145 ppms per absorbance units. The analytical sensitivity is equal to the slope divided by the standard deviation, which would be 0.0145 divided by 0.031, which gives us 0.468 ppms per absorbance units. Estimating the dynamic range, well, just looking at the plot, we could see that the first four had a pretty linear slope without any calculation. But if we calculated the slope between these points, we would find that the first 4 points do in fact have a slope of 0.0145. After that, the slope changes. So we can estimate the dynamic range as being linear up to 100 ppm. If the average noise is 0.031, then the limits to detection would be 3 times the noise divided by slope, or 3 times about 6.4 ppm. The molar absorptivity is again just going to be easy to calculate if we're given the size of the cuvette that's defining the path length. So the absorbance unit can be acquired from any of our data points, 0.3 is equal to the molar absorptivity. In this case, the path length is 1 times the concentration at that absorbance is 25. So I just picked one data set to plug into that, within the dynamic range, of course, and the molar absorptivity. Absorbance units per ppm centimeter.